Hello बच्चों, let's read this question. Question says fixed amount of an ideal gas contained in a sealed rigid vessel V is equals to 24.6 liter at 1 bar is heated reversibly from 27 degrees centigrade to 127 degrees centigrade. Determine change in Gibbs energy in Joule if entropy of gas, that is S, is equals to 10 plus 10 raised to the power minus 2 T in Joule per Kelvin is given. Here we have to find out change in Gibbs free energy, that is del G. So now we can write the relationship between, here in key concept we can write the relationship between Gibbs free energy, that is represented at del G, and enthalpy, that is del H, and entropy, that is del S. So we have to find out the relationship between these. So we can write del G is equals to del H minus T del S. This is the relationship when we determine the change. But here if we are talking about only Gibbs free energy, enthalpy and entropy, then we can write G is equals to H minus Ts, and also H is equals to U plus PV. Here U is equals to internal energy, so we can write that G is equals to U plus PV minus Ts. So here now we can write that this dG is equals to du. Here change in Gibbs free energy is equals to change in internal energy plus P dV. dV is change in volume plus VdP, change in pressure, minus TdS minus SdT. Now here we can write W is equals to 0, so that the value of PdV becomes 0, and also here W is equals to 0, dV is equals to 0, so dV is equals to dQ, that is also equals to TdS. So hence we can write dG, change in Gibbs free energy, it is equals to TdS, because here this value becomes 0, so TdS plus VdP minus TdS minus SdT. So here we can write dG is equals to VdP minus SdT, because this TdS will get cancelled out by this TdS. Here it is VdP minus SdT. Now we can write del G is equals to, from here del G can be written as V del P, that is change in pressure multiplied by volume, minus integration of entropy dot dt, because here entropy is given, that is temperature dependent, so we will integrate with respect to temperature. So here let's say this is our equation first in this. Now we can integrate this, so we can write VdP. What is the value of VdP? VdP is equals to volume, that is P2 minus P1. This is our equation second here. Now we can write P2 by P1 is equals to P1 by, here if we write the volume is constant, then P2 by T2, it is equals to P1 by T1. This is from ideal gas equation, so that P2 upon T2, that is equals to temperature. So here temperature is 127 degrees centigrade, so it is equals to 400 Kelvin, and this 27 degrees centigrade is equals to 300 Kelvin. So we can write T2, it is equals to 400, and P1 is given as 1 bar, so 1 divided by T1, that is equals to 300. So we can calculate the value of pressure P2. So from here P2 comes out to be 4 by 3 bar. Now we can substitute the value of P2 in our equation second. So we can write that here VdP is equals to, volume is equals to 24.6 liters. So 24.6 multiplied by V2, that is 4 by 3 minus V1 is equals to 1. So the value comes out to be 8.2 liter ATM, and 1 liter ATM is equals to 101.6 joules. So we can convert this value into joules. So here the value is equals to 820 joules. This is our equation third. Let's say this is our equation third. Now we can integrate the value of SdT. So here we can write the value of SdT, integration of S dt. So S is equals to 10 plus 10 raised to power minus 2 t dot dt. Now the integration with this, so this comes out to be integration with limit t1 to t2. Now we can write that here the value is equals to, the value comes out to be 10 multiplied by t2 minus t1 plus 0.005 t2 square minus t1 square, t2 square minus t1 square. So the value of s dt comes out to be 10 multiplied by 100, because t2 is equals to 400 and t1 is equals to 300. So 10 multiplied by 100 plus 0.005 multiplied by 400 square minus 300 square. So we can write here 16,000 minus 9,000. So the value of s dt comes out to be 1350. Let's say this is our equation 4. Now we have to calculate the value of change in Gibbs free energy, so that we can write del G. So del G, here it is, del G is equals to VdP minus S integration of SdT. So the value of VdP comes out to be 820 joules. So 820 joules minus 1350 joules, this comes out to be minus 530. This is equals to minus 530 joules. So this will be the correct answer of change in Gibbs free energy. Hope you understood it well. All the best and thank you.